All right. Welcome, everybody. Good afternoon. Hello, everybody. You all need to have a lot more energy than me because I just flew across the pond to arrive here like an hour ago. So you all need to keep the energy up today, and I will do my best to follow suit. Thank you all for coming on a weekend to hang out at the OHDSI Europe Symposium. I hope that many of you enjoyed the vocab workshop and the intro. How many of you attended the vocab workshop earlier today? Good crowd, good. And how many of you attended the intro to OHDSI? Great. Wow, that's awesome. Cool. Okay, so first of all, why don't you give a big hand to your instructors from this morning? All right, good. I'm going to hope that wasn't the highlight. So today we are going to do one half of a full day workshop that Anna and Talita and Victor and Gowtham and Abstentia and I have prepared for you, which is all about phenotype development and evaluation. And this is a workshop, so you all are going to do work. And so we are going to provide some portions of tutorials so to familiarize yourself with some common language and some tools and processes that we've evolved in the OHDSI community over the last many years. But actually, at least half of the time we're going to spend together over the rest of the afternoon today, as well as in the morning tomorrow, is that you all are going to get the opportunity to contribute to the OHDSI community by developing and evaluating a phenotype yourself. So, how many people are excited about that? Try again. All right. That still seemed only half-hearted, but hopefully you'll get better. I promise it'll be fun. So what I'm going to do, just to kick us off, is try to motivate why you should be more excited than you just were about phenotype development and evaluation. Going to provide some common grounding of some terminology that you're going to hear Anna and I using throughout. We're going to try to do our best to be pretty consistent with this throughout the sessions. And then after that, Anna and I are going to be tag teaming and going back and forth doing deep dives into specific components of the phenotype development and evaluation process. And after each section, we're then going to have you all break into groups and work on it yourself. So, our agenda, we're already starting 15 minutes late. I will recover some of that in this intro part. But basically, what I'm going to do is kick us off just to provide you all an overview and an intro to the task that you all are going to have. The first breakout set, or the first specific deep dive session is going to be focused on building concept sets. So those of you who attended the vocabulary workshop will hopefully hear some things that are common there. Anna will go through that, and then you all are going to break into groups and build your own concept set. We will take our appropriate coffee break, and then when we come back, we're going to do a deep dive session on how to build cohort definitions, and we'll specifically talk about the principles of thinking about the development of cohorts, as well as the application of that using the Atlas tool. And then you all are going to do a breakout where you are going to build your own cohort definition. And then we're going to come, at the end of today, we're just going to try to capture some lessons learned from you all about what that experience was doing that hands-on activity. While you all go drink Heineken and eat bitterballen or do some other Dutch thing this evening, Anna and I, and particularly Gowtham Rao in absentia, are going to be taking the cohort definitions that you create today, and we're going to be running them across a network of databases so that you can then evaluate those definitions bright and early tomorrow morning when we start our session again. Why I'm telling you that now is it's really important that you do your exercises seriously, because otherwise this entire workshop will really suck if you don't get your cohort definitions done by the end of today. But assuming that you get them done today, you'll be able to actually see the implications of what you've done today in tomorrow's session. And in the morning, Anna's going to go through the ideas of phenotype evaluation and specifically provide you all an introduction to measurement error and how we think about different types of error in definitions. And then you all are going to get the experience to work together to evaluate the cohort definitions that you create today. And at the end of tomorrow, you all are going to report out as teams about whether or not you now have created a cohort definition that is ready to be submitted to the OHDSI community and into our Phenotype library for everybody to be able to reuse in posterity. Does that sound like a good plan? All right. All right. So the one thing that Talita and Victor are going to be doing is, while we're getting ready, is going to be paying attention to where you all are sitting and how many of you are here. So while I do encourage you to like stand up and stretch your legs and whatever, don't switch your seats while we're talking, just until Talita and Victor figure out how to assign you guys to groups. We are going to stay in this room, although I can see from Polina that it's maybe a little warm. And I know that I'm very warm, but that's just because I just ran here from an airplane. We are going to stay in this room through the first exercise, and then after the first exercise, you'll have the opportunity when you're doing your breakout sessions to go use the space. I guess where you guys had lunch, there's lots of like open space, and then there's also some other rooms, so we'll have flexibility about that. Just as long as we can like stick to time and make sure that we're back after each breakout activity, that's what we'll be looking for. All right, so with that, let's get started. So, those of you who are in the intro class probably heard a lot about why we think using the OMOP common data model is a good idea. The basic premise is that by standardizing data, we can standardize analytics. And standardizing analytics means we can generate evidence in some sort of reliable way and disseminate that evidence out into the world. It turns out that the one thing that almost all of our standardized analytics have in common is that they use as input cohorts. So if we've got a whole bunch of databases across the OHDSI network that have been standardized to the OMOP common data model, we can answer lots of different types of questions. So for example, I apologize, I didn't actually get to see the intro thing, but Anik was giving the intro class. Did she go through her treatment pathways work? Yes? Yes? Okay, cool. So treatment pathways, basically the basic idea there is that you can look at the drug utilization for a given disease across all the different alternative treatments and look at the sequence of that. We can also do incidence rates analysis. So you want to understand for a given population how often some outcome can occur. We can do population level effect estimation. So we can do comparative cohort designs to actually estimate a hazard ratio for any given analysis. Or we can apply self-controlled case series designs. And we can also develop patient-level prediction models where we're applying machine learning algorithms to try to predict which patients are going to experience some outcome. All of these different types of standardized analytics have one thing in common, which is that they use as inputs cohort definitions. So a cohort definition is a specification to identify a set of persons who satisfy one or more criteria for a duration of time. And we're going to try to harp on this throughout this session, because basically over the next 2 days, what we're going to focus on is explicitly this task of getting you to a cohort definition that you can use as an input to any of the different types of analysis that you could imagine wanting to do. And so if you wanted to do a treatment pathway, you need kind of two sets of cohorts. You need a target cohort, which represents the population of interest, maybe an indication. And then you need event cohorts. Those would be like the periods of time that you're exposed to a given drug. If you're doing an incidence rate analysis, you need some sort of target cohort, which is like your denominator population. You need an outcome cohort, which is going to represent those events that you're looking for within the denominator. So think of that as like your numerator. If we're doing a comparative cohort study, we oftentimes have some target exposure, the effect that we're actually interested in, a comparator cohort, and an outcome cohort. If we're doing a self-controlled case series design, we have a target cohort and an outcome cohort. If we're doing a patient-level prediction, we have a target cohort and outcome cohort. All of these are just cohort definitions. All of them meet this same definition, which is a specification to identify the set of persons satisfying one or more criteria for a duration of time. All of them should go through the phenotype development and evaluation process, which is what we're going to be walking you through over the next few hours. For those of you who have seen some of the recent work that we've done in the OHDSI community, we've been really pushing hard towards the idea that we can develop an open science system that can generate reliable evidence that could be provable. And we've laid out this waterfall diagram. This is something we've been actively working towards developing, this idea that rather than a research question being some particular random hypothesis, that we could build a system whereby we could determine whether or not data were fit for use. We could determine whether the phenotypes that were developed were appropriate. We can determine that our analyses are appropriate, and ultimately, at the end, we can actually have evidence that we can trust. But the middle of this picture and the heart of this is phenotype development and evaluation. And this picture, one of the things that Martijn has now presented several times is this idea that we want to have explicit go, no-go criteria to determine whether or not evidence is reliable. We can't just do a study and then wave our hands and say it's observational research so we can't trust it. We instead need to think about how we generate evidence that we know we can trust because we can prove that it's trustworthy. And just as it's sometimes easy to say, well, there's a given database and I know I can't use it for a given question, or it might be easy to say for a statistical model that it fails some sort of assumptions that are based on the model. The cohort definitions, I would actually argue, is the area where it's easiest to go wrong and hardest to go right, and yet is largely the part that gets under-recognized. You know, in a typical manuscript that I read or review, I see a whole paragraph talking about the data and why it's good. I see 2 paragraphs describing all of the statistics, and then I get like a half sentence that says, and the outcome was defined by 410 star, or some random nonsense representing a code. I hope by the end of this next 2 days that you're going to realize that that cohort definition component in phenotype development evaluation, at a minimum, should be on equal footing when you're thinking about appropriateness of data and appropriateness of methods. And maybe you will even be convinced that, that this is actually even more important than some of those elements, because if we don't get this right, we really can't rely on the evidence that we're generating at all. All right, so George Ripsack published this paper, and I like the definition of phenotype that he used in this paper, so I'm going to cite this and try to stick to it. He defined phenotype as a specification of an observable, potentially changing state of an organism. And why this is important is, one, this idea of observable means we're going to be like looking for something in our data. And this idea that it's a potentially changing state covers this notion of time. The idea is that the phenotype can be applied to patient characteristics inferred from whatever observational data that you have. The goal is to actually try to identify people who have a particular disease based on some logic that you're going to apply to try to guess who those people are. And a phenotype algorithm, or what we're going to refer to as a cohort definition, is some logic that could be defined, can be generated by domain experts or knowledge engineering or probabilistic processes. But ultimately, at the end of that process, what you're doing is you're applying some logic to data to try to identify people who satisfy your definition that you're interested in. And this notion of, so that's why I'm going to restate this definition and try to go through it to try to make an argument why you need all these pieces. A cohort is a set of persons who satisfy one or more inclusion criteria for a duration of time. Now, this is actually not necessarily the definition that you might read if you were to look up the word cohort in an epidemiology textbook, or if you just were like casually throwing around the word. Sometimes what you'll see, for example, is that, or let me back up. The consequence of this definition, a set of persons who satisfy one or more criteria for a duration of time, there's multiple consequences. One is, one person can belong to a cohort one or more times, because one could enter a cohort and then leave a cohort, and that would represent a duration of time. And then sometime later, they could enter that cohort again and leave that cohort. Example that you may be thinking about is, how many of you had a COVID reinfection? Okay, so you belong to the COVID cohort multiple times, each time that you were infected. And when we were starting at our original OHDSI study-a-thon on COVID, we created a definition for COVID, and that definition basically said there was people who didn't have COVID, and then there was a moment when they had COVID, and we just classified them as COVID forever. And at the time, way back in, whatever that was, March of 2020, we didn't know that we were going to actually see these people who were going to stop having COVID and then later have COVID again, even though Talita kept saying that her doctor refused to believe that she kept getting it over and over again. And so we were in a situation where the cohort definition evolved to try to represent that span of time. The other thing that's important here is that, based on George's definition, we need to be able to observe something in the data to be able to apply logic to find a person. And so this idea of an inclusion criteria is going to be that we're going to have some sort of logic where we're going to look for something in the data in order to present a person as satisfying the criteria. This is particularly important because sometimes, if you're reading some papers, you'll see people who just describe, a person who doesn't have a disease. And the challenge there is that if you're thinking about the negation, there is not a single moment in time when you don't have a disease necessarily, but rather we need to have something that's observed, whether that be that you were observed to have a visit, have a condition, have a drug, have a measurement, or what have you, and that there's some span of time that you're representing that health state. That span of time we refer to as a cohort era, so that's the continuous period during which a person satisfies the inclusion criteria. For some diseases, some chronic diseases, it may be that once you have a given disease that you're going to stay in that disease state for the rest of your life, and that's totally reasonable. The duration of time would be the rest of your time observed, but it could also be, in the case of COVID or any acute disease, that you could actually have a disease, have it resolve, and then maybe potentially recur. Whoops, what did I do there again? Ooh, let's push that again. That's a sensitive little button. Ooh, okay. All right. So when we talk about a cohort, we're actually talking about the people themselves, and what you all are going to be working on is creating cohort definitions. That's the logic, it's the specification for how to identify the cohort. Consequence of this is that you all might create a totally valid cohort definition that finds no people. And that's actually okay. It means that the thing that you required to observe just hadn't been observed in any given database. Take, for example, looking for COVID prior to 2019, you probably won't see it, but it still could be a valid definition. All right, so remember these words, cohort, cohort era, and cohort definition. We'll try to use them throughout. A couple more words, just to put some vocabulary in place as we go through this. Those of you who were in the intro, actually I guess probably both of the workshops earlier today, you probably heard us talk about domains. So domains are going to be the particular sets of allowable concepts in the standardized fields in the common data model. Primary domains will be working with conditions, drugs, procedures, measurements. Those are the data tables in the OMOP common data model that we're going to look into to try to identify these observable elements that we have. To look in a data table, we're going to be looking for specific elements in that table, and that's where we're going to use our concepts. And you'll hear us using the phrase concept set. That's to represent an expression that defines one or more concepts encompassing a clinical entity. So, for example, we may want to define the set of codes or concepts that represent the clinical condition of type 2 diabetes, or the set of drugs that treat diabetes, or measurements for hemoglobin A1C. Each of those clinical ideas can be represented by multiple concepts, and a concept set is just an expression to represent that list of codes that you'd identify. Now, our domains, some of them have domain-specific attributes that we may want to use. We probably won't see too many of these, but I want you to be aware that part of the reason that the OMOP common data model exists in the way it does, and the reason we separate conditions from drugs, from procedures, from measurements, is because each of those domains may have different elements, and those elements can be used as part of the criteria. So, for example, in our drug exposure table, there's a field for day supply, and it would be totally reasonable to say, I want to find people who took a drug for which their day supply was at least 30 days. And that would be using that domain-specific attribute as part of the criteria to identify the persons who satisfy the inclusion criteria for a duration of time. And then the last thing that I'll highlight here is that you're going to hear us talk a lot about temporal logic. So whenever we are creating these inclusion criteria, we will be applying rules where it isn't just about finding a code, but it's going to be when did we find a code in relation to what? And so very common, we may say something like, for example, we need to see a condition within 365 days of treatment of a drug, for example. And that temporal logic, that notion that you're using some time window bounding information that you're seeing is going to be part of all of these logics. The reason why I'm harping on these words is because one of the things I observe in the literature today as it relates to phenotyping specifically is there's a lot of ambiguity in how people talk about cohorts. And the most common thing that I see is a statement that says the cohort was defined by, and then they just rattle off a list of codes. And by listing a set of codes, that doesn't actually tell you what domain was being looked at, what temporal logic was being required, or what way in which those codes were being combined together to represent finding the set of people. And so what we're going to try to get you in the habit to do over the course of this course is, as you're working through your definitions, is to create logic where you're really describing to try to find that set of people who satisfy the criteria, which embedded in there will be those codes, but it's much, much more, to be more precise about it, it can't just be a list of codes. So the general workflow that we're going to walk through is pieces. Anna's going to walk through concept set expressions, this idea that you want to create a list of concepts that represent those clinical entities that you're going to go after. From there, I'm going to walk you through how to create a cohort definition logic. And we're going to walk through a three-step process of defining our entry events, defining inclusion criteria that are applied to those entry events, and then defining an exit strategy to represent that duration of time of when do you enter a cohort and when do you leave a cohort. And then tomorrow, and importantly, as you go through this process, you might actually find yourself iterating through this process, that you'll create a concept set, and then once you start working on the logic, you realize, hey, I need to make a new concept set, or I need to revise my concept set. And that can very much be an iterative process. Tomorrow morning, you're going to get exposure to cohort diagnostics, which is one of the tools in the OHDSI toolkit that we are using for phenotype evaluation. And the idea here is, now that you've created a cohort definition, you can run it across any database across the OHDSI community and evaluate empirically what's happened in terms of finding that set of persons who satisfy those criteria. And tomorrow, I expect that you'll be looking at cohort diagnostics and you'll either determine that the definition you've created is good enough and ready to go, or you'll actually learn how you would want to iterate back to revise your cohort definition and run that again. So this is the general iterative framework that we're going to be walking through, and you're going to get hands-on experience doing each of these three steps over the next 2 days. I want to highlight that within the OHDSI community, we've got lots of phenomenal researchers that are working in this general space of phenotype development and evaluation. You're going to get hands-on experience with Atlas for purposes of building concept set expressions and cohort definitions. There is also a tool called Caper, which allows you to write a cohort definition directly in R, and that's a phenomenal tool that's quite useful. We won't be using it today, but that's only for time purposes. I strongly encourage you to take a look at that. We also won't be covering probabilistic phenotyping in today's workshop, but I'll highlight that there is a tool in the community called Aphrodite that allows for doing that. We have a range of tools that allow for evaluation. For purposes of this session, we're just going to be focusing on cohort diagnostics, but I'll just highlight that we also have tools to do case adjudication, as well as tools that estimate sensitivity and specificity. And we have a phenotype library, and I hope that at least somebody in the group gets sufficiently motivated that your work that you do on your phenotype over the next 2 days will be something that you want to carry forward and make a contribution yourself to the community with a definition that everybody else can reuse for their research purposes. All right, so cartoon schematics. So what do we have in our data? So across the different domains that I've kind of represented as cartoon colors here, so we've got conditions in orange and drugs in dark blue and measurements in light blue. There are individual observations represented as time-stamped records in a given patient's record. And so you can see here that I've just shown examples of records for type 2 diabetes, hyperlipidemia, hypertension, et cetera, drug records for metformin, lisinopril, measurements for hemoglobin A1C, et cetera. So this is the data. This is what you've got in the OMOP Common Data Model. You've got a whole bunch of time-stamped observations for a given individual where a person had some sort of event on some particular date with those domain-specific attributes that may be available, such as measurement values. So this is what we've got. The challenge is that this picture itself doesn't necessarily tell us about the set of persons who satisfy some criteria for a duration of time. If we wanted to represent what we've got in terms of what we might actually want to infer about this person, we might instead say that what we would want to know is this person has a span of time that they have type 2 diabetes. They've got a span of time that they've got hyperlipidemia. They had an event of an acute myocardial infarction for some duration. That there's some period of time that they were a metformin user and some period of time that they were obese. If we had these intervals of time that represented the health states, we could use these things to draw inferences, like how often is type 2 diabetes correlated with obesity, for example. But in order to do that, we have to be able to take those individual events and turn them into these periods of continuous events satisfying this criteria for a continuous duration of time. So that's what we want to do, is we want to basically take our data and turn it into these records that we can then rely on. Now here's some of the challenges when we do that translation from the individual data down into these periods of time that we're going to represent as our cohort definitions. It is possible that, for example, if we only have the observations of type 2 diabetes, for example, as condition records, it could be that we have index date misclassification. That is, we've said that a person has type 2 diabetes for this duration of time, but maybe we got the start date wrong. In this particular case, for example, if I only relied on those condition records, I might have missed the fact that this person already had taken metformin in the past. And they already had a hemoglobin A1C greater than 6.5. So they may have already been a type 2 diabetic well in advance. So if I only define my cohort definition based on diagnosis codes, I could potentially be getting my start date wrong. I can also have specificity errors. So here we see this cartoon person had a single record for hypertension. One might say, well, once a person has a code for hypertension, I'll consider them a hypertensive for the rest of their life. But it could be that there's some reason that a person gets a single hypertension code and that we don't actually believe that that's actually a real indicator of the disease state. For example, it's pretty unlikely that a person who has hypertension would only get one code ever. It's unlikely that they wouldn't be treated with an antihypertensive treatment. It's pretty unlikely that they would have a systolic blood pressure of exactly 120 if they were truly hypertensive. And so there's concerns about false positives in our cohort definitions. And then there can also be concerns about sensitivity error or false negatives, so failing to infer disease that does exist. Obesity is one that very commonly comes up either because a data set may not have some values like a body mass index or because one doesn't know how to make some sort of inference. But these types of errors, sensitivity errors, specificity errors, index date misspecification errors, these are the kinds of things we want to be worried about when we're trying to apply a cohort definition into a data set and know what kinds of mistakes could potentially be introduced by that phenotype definition itself. And so tomorrow, this is really what Anna's going to spend a lot of time going through as you all use cohort diagnostics to identify these types of errors. All right. So our objective when we're going to evaluate phenotypes is to estimate the extent to which that inference from the phenotype algorithm is consistent with the true health state of the patients. So we're going to try to actually estimate measurement errors of various sorts. And when we decide that a phenotype is fit for use, really what we're saying is the amount of measurement error that we have estimated, we deem that to be sufficiently low for the problem that we're doing, whether it be a characterization or an estimation or prediction study. We need to be able to know that we can manage the error. This is actually kind of a somewhat, I'll say, big idea in that most papers that you read don't have any estimation of measurement error or have some very hand-wavy statements or claim that they did validation by doing some sort of sample chart review and give you some weak positive predictive value estimate. But really, if you can't understand the total error that you're dealing with, you're in a challenging situation to be able to interpret the results of a cohort definition. So that's why whenever we talk about phenotype development, we always say it's phenotype development and evaluation to include that. So steps for developing a phenotype. Now that you know that our goal is to evaluate and make sure that we have sufficiently low error, I'm going to walk you through the steps to think about the process, and this is going to be relevant as Anna gets into creating concept sets. First task is going to be we want to identify the people who might have the disease. Our aim for this is to increase sensitivity, find as many of the cases as we possibly can. And so your task is going to be to create a concept set for each of the domains that we need that can help us identify all the possible ways that a person could enter the health state of the cohort that you're studying. Once we finish that task of trying to maximize sensitivity by improving our concept sets to identify entry events, then we can move on to stage 2, which is going to be apply inclusion criteria. So this is going to be restrict people who we don't believe have the disease. And here, the idea is that if we apply an inclusion criteria, we can start removing people that we had identified before because they don't qualify for some reason. The goal here is going to be to increase our specificity, or if you're interested in paying attention to positive predictive value, you can do that. And here you'll be using temporal logic to say people have entered the cohort based on your entry criteria. Now we can actually say, how are we going to remove them based on other observations that you might have seen? And then once we've now thought about sensitivity, and then we've tried to maximize our specificity, we're going to then worry about our index date misspecification. And here, the task is going to be to look at our cohort and determine whether or not we've identified the correct start and end date for each of those episodes of care. And the goal here would be to try to reduce that error as much as we can. And throughout the exercise that Anna and I will do together, we're going to use type 2 diabetes as an example of just one disease state. But when you all have your phenotypes that you're working on, you can walk through these exact same 3-step process to try to think through this process as you're developing your phenotype. All right. So last thing I'm going to say, and then I'm going to turn it over to Anna, is about what you all are going to be responsible for doing. So today, we are going to break you all up into small groups. Actually, I'll take 1/2 step back. 2 weeks ago on the OHDSI community call, George Ripsack talked about one of the large community activities that we are going to do, which is to do large-scale incidence characterization across as many diseases as the community can come up with. The only dependency for that is we need the phenotypes to be done and in our phenotype library. So we asked the community, what phenotypes do you all want to see done? And we asked people to identify them and to vote on them. So we got a whole bunch of input on a Tuesday call a couple weeks ago. I'm using that list I'm going to restart my computer. I don't want to do that. We're using that list that the community had voted on as the activity that you all are doing. Very purposefully, because I don't want you to be thinking about this as some sort of hypothetical exercise. I really hope that you'll take the thing that somebody actually wanted and carry it to completion over the next 2 days, which is a very reasonable task. The way we're going to do this is you're going to break into groups of like 4 or 5. Talita and Victor have hopefully figured out approximately what that's going to be. We've got 10 phenotypes, and we're going to assign them to your teams. Exercise 1, after Anna shows you how to make a concept set, is you're going to sit in this room and you're going to build a concept set as a group. Exercise 2, after I teach you how to build a cohort definition in Atlas, you're going to use that same team and you are going to go build a cohort definition in Atlas. Tonight, Anna and I are going to make sure that that gets run with Gowtham's help. And then tomorrow, you are going to be merging your teams because at least 2 groups in this room are going to independently be trying to do the same phenotype. And you will be able to compare and contrast to see how similar or different the result is that you generated. And you'll be able to evaluate your alternatives using cohort diagnostics. And then you will present the results back to the group. Is that, I know I went through that very quickly, but is that kind of clear? Yeah. Okay. All right. I sent an email to everybody who was on the registration list. If you didn't get an email from me, we'll make sure that we get it to you when we do this breakout. But just to show you a high level, these are the 10 phenotypes that were identified by the community as things that we wanted to do. Anna and I went through and identified clinical descriptions that we think are sufficiently appropriate for this exercise. And so as Talita and Victor break you up into groups when we get there, just know that you're going to be assigned a group number and a phenotype. And you now have in your email a link to read about that disease in case you're not familiar with it. And Anna's actually going to walk through how using that clinical description will be relevant. So you should all have this email. If you don't have the email, Yes? Don't have the email, okay. So, Victor, would you mind grabbing emails? So if you didn't get an email from me, just keep your hand raised, and Victor's gonna run around and get your emails. And we'll make sure that you send this. Or the other thing you can do is very simply is literally it's just that URL there, but it's kind of a gnarly URL. So probably best just to have a piece of paper to pass around to get emails from everybody. And I'll just make sure you send it all to you. All right. So so you should all be able to get on Wi-Fi from Hotspot. And it should be free, and just you click approve to get on there. All right. All right, so with that, now that you know what your homework's going to be, Anna's going to teach you how to create concept sets, and that'll be your first exercise to do on your own.
Thanks so much. Well, I'm not supposed to talk into this stuff. Well, as we said, right there, we went through this. It doesn't feel loud enough. Oh, that's loud enough. So we already said that the concept set expressions are the collection of codes that you use as building blocks in your cohort definition, right? So you can use it for entry criteria, you can use it for inclusion and exclusion criteria, and it's really one of the first pieces that you want to build. And how would you even figure out what kind of concept sets you want to create? Throughout these 2 days, for the purposes of the demos, we're going to be using type 2 diabetes as the example. So this is one of the clinical descriptions that I built off of the guidelines and literature. And the clinical description is really something you want to start because even if you have medical experience, you still want to write down this essential pieces of the information about a given disease. A, because it will make it easier for you to wrap your head around concept sets and criteria, and B, because you will use this piece of information for your phenotype evaluation. And if you're working in teams, then somebody will create this clinical description for you, or you will read it up online, and you will use this piece of information as the clinical knowledge to guide your phenotype evaluation, creation and evaluation. And essentially, as I was speaking, I hope you skimmed through this description, but basically it describes what kind of symptoms you're looking for in patients with diabetes, what it can be treated with, what are the comorbidities, and then what the long-term complications are. And essentially, the concept sets to consider here are all of these elements. So first of all, you can consider when you create a cohort definition for diabetes, you can think of diabetes condition codes, or you can think of measurements like hemoglobin A1C, that would be a concept set. Or maybe you can think of the concept sets that will be used as your exclusion criteria, like other conditions, like type 1 diabetes. Or another piece of information is treatment, so that would be yet another concept set that you may or may not use in your core definition. These represent different domains. For now, because we have limited time, obviously we're going to focus on conditions. So both the demo and your exercise will be building condition concept sets, but there are, of course, other principles and tricks of how you would do that for measurements and drugs. And if you're interested in that, you can spend your free time over a break to ask about that. And there are two useful resources. One is athena.odyssey.org, which is the browsing server for vocabularies. And then another one is atlasdemo.odyssey.org that you'll be using in your exercises. And let's say we want to build a concept set for condition of type 2 diabetes. If you go to Athena, you would type in something like type 2 diabetes mellitus, right? That's one of the approaches, just type something in. And what you will see is actually a bunch of different codes, right? So we specified that it's gotta be standard because we use standard codes in Odyssey, but then it's just like all sorts of things. So it's really unclear what to choose. And this illustrates a larger problem with the building concept sets, is that coming up with the comprehensive concept set is really hard. Because if you ask your clinician about the codes that they use for billing, their answer will only represent their own knowledge. And we know from the literature that people use all sorts of different coding and billing practices, so you really cannot rely on one person's opinion if you're doing a study across the institution or a network study. So just asking somebody for the codes will not work. Then if you would try to navigate the ontologies, you have the huge space, and as we have different data sources are extremely different. We did a study on 22 data sources when we looked at the overlap of code utilization, and we saw that less than 0.1% of the codes can be found in all of the databases. So that also means that if you're going to the literature and taking the concept sets that they published, that may not reflect the code utilization in your own database because somebody else used a different data source, maybe different country, and who knows what. So really, the challenge here is that we want to ensure that our concept sets are comprehensive. And for that, we need to have some sort of tools that will guide us, will show us what's in the data, and will provide us with the rationale on how to select all of the possible codes. And with that, I will switch to demo. Actually, oh,
We'll just use the Atlas demo.
I can also use slides.
No, it's fine. I just the reboot it.
Oh, we're not using yours. Okay. So I will use Atlas demo. I saw a couple of people from the last week Oxford summer school, so they are already familiar with some of the pieces I'm going to show you. So essentially, the task at hand is to create a comprehensive concept set. And for that, you need to have some sort of knowledge about the data and which codes to choose. So with that in mind, we built into Atlas the tool or approach that we developed for this specific case. And that tool that we called Phoebe, that is represented by this green shopping cart, essentially uses the data and uses ontologies to recommend you the concepts. Now, the decision about whether to include them or not depends totally is up to you. What it does, it recommends you something so that you can make sure that you're not missing the elements, that you actually observe the space. And we will type something like type 2 diabetes and diabetes. And we'll click on the shopping cart to initiate this process. And it will start running, will tell you that it's loading recommender concept set. And what it uses at the moment is the data from 22 data sources and the code utilization that we collected. So to orient you here, essentially it already picked the starting point for you. So you don't have to guess which code do I need to start with. It already told you that you should start with type 2 diabetes mellitus and all of the descendants. How does it do it? Well, if you look at the included codes, and if we order by the descendant record count, which is the record count of all of the descendants, we will see that type 2 diabetes mellitus is on the top, and with the descendants can be found in 1,344,000,000 records. So basically, Phoebe looks for the most commonly used term that lexically overlaps with your source string. And this is how you know you should start with it, because inclusion of this code will bring you the most patients, potentially. Now, that also has to be evaluated later on, but at this point in time, we want to get as many relevant codes and patients in, because we're trying to increase our sensitivity. And then you would click on the recommend button, and what it will bring you to is the list of recommendations. Now, just to orient you here on your left side, you have types of recommendations. So you have lexical recommendations, when we did some lexical matching with the with the terms. You have patient context. This is actually the recommendations coming from co-occurrence from the real patient data. And we also have ontology-derived recommendations that are based on the OHDSI vocabulary hierarchies. And then I already said about the standard record count. And all of the recommendations right now by default are sorted by the descendant record count because you want to prioritize your review based on how many patients you potentially can get in with this code, right? So it makes sense to start with the terms that get you the most patients. And then at the end, the very last column also has count, which can be useful. It actually tells you by how many approaches this term was recommended. So if it's 3, then it was recommended by 3 different types of recommendations. And you can see here that one of the very first things, surprisingly, is essential hypertension. Now, how come? Well, in fact, this term accounts for a lot of records because a lot of people have hypertension, and that recommendation was derived through the patient context because a lot of people have diabetes and essential hypertension. Now, we don't want to include this code because it's absolutely not relevant to this concept set. But as we go down, we start to see some of the interesting things. First of all, we have the concept of just diabetes mellitus without specifying any type, whether it's 1, 2, gestational, what have you. Now, probably we don't want that. But wait a second. If we look at the record count, which tells you how many records this term alone has in all of the databases, we will see that this term is used, or this code, is used in 31 million records. So there are patients who are coded with the code of just diabetes mellitus. And now we can make some sort of judgment of whether this is type 2 or type 1. But let's table it for now because it's a slightly more complex discussion. There is a much simpler recommendations. Like if you go down, you see disorder due to type 2 diabetes mellitus that for some reason was not included in your initial concept set. And that accounts for, with the descendants, for 465 million records. So if you were doing a network study on those 22 data sources and you did not include this code that clearly tells you that it's type 2 diabetes, you'll be losing 465 potentially million records. So we definitely want to include that. And as we go down, for the first run, I'm just looking for something that says type 2 diabetes because I don't want to think hard. And as we go down, we will see other terms that also tell you that it's type 2 diabetes just in different letters. Like for example, here it's type 2 diabetes mellitus uncontrolled that accounts for 158 million records. You don't really have to guess here, you definitely want to include that. So we can start with that and with these 2 recommendations. And we can scroll down and add these with all of the descendants. And as we do that, we add that to the concept set. And we see that now all of these 3 terms are included, and the recommendations are refreshed automatically. So now, because in the included concepts, we have 127 included concepts, many more than what we used to have, of course, now we have more recommendations, because recommendations are regenerated all the time. So now we really start to see a very broad things like arthropathy or hypertensive disorder, because again, our concept set grew and then we got more recommendations. So at this point of time, we may choose to prioritize our review based on the things that were, just a second, based on the specific types of the recommendations. Like for example, we may want to look first at the ontology parent recommendations. And now we keep seeing this thing that we said we will table for now, like diabetes mellitus or complications due to diabetes mellitus. And again, as I said, it doesn't say which type of diabetes it is, but it's actually a lot of records. So potentially, if we assume that those people actually have type 2 diabetes, we're missing a lot of patients by not including those codes. And this is something we can actually check later on in our cohort diagnostic. But for now, because we want to increase our sensitivity, and we know that most of the cases of diabetes are type 2 diabetes, we will include these codes. We will include the diabetes mellitus without the type. We will include other things that we can see here that belong to diabetes. And actually, as we scroll down, we have complications, diabetes mellitus without complications, all sorts of things. So let's say we want to add that. Let me unclick that. And as we, well, basically as we go down the list, we would see other things that, again, say that it's diabetes but do not really specify the type, like, for example, diabetic poor control. So similarly, using the same logic, we may want to consider that this is, in fact, type 2 diabetes, and then later on evaluate whether that's actually true when we get to the phenotype evaluation. But at this point, because we want to make our concept sets as broad as possible, we want to include all of these things. And we have type 2, type 1 diabetes, we definitely don't want that. But in fact, as we scroll down, we start to see a lot of the terms that only specify diabetes without specifying the type. So what we want to do, and this is a little trick, is we want to grab this broad diabetes mellitus terms, and we want to add them with the descendants to the concept set and see what we get in the included terms. Because now we know that we added a bunch of really big hierarchical trees. So at this point, we want to examine what's actually in our concept set, because we, again, going back to the concept set expression, we added type 2, we added type 2 uncontrolled, we added disorders due to type 2, and we also added all of these terms that do not specify the type. Now it's a really big list, it's like 500 concepts. So we want to examine what we actually get. And I think I want to make it smaller because I cannot, oh no, let's keep it this way. So now we want to examine what we see in the included concepts and what our concept set actually look like. And what we see is diabetes that we said we're going to include, type 2 diabetes, complications, again, type 2, diabetic, type 2. So far looks good, okay? So far we made this assumption that we will add generic diabetes, so far so good. But now we hit type 1 diabetes, which happened to be a descendant of a term that we added. So we definitely do not want type 1, because type 1 is absolutely something that is different from type 2, right? So what we will do here, and this is what I was referring to as a trick, is we will add this term with all of the descendants as the exclusion part. And you explain it better. I don't know how to say that. We will exclude them from our concept set. So now our concept set expression, if we go back, we will see that we have diabetes type 2, and we added type 1 and excluded it because we don't want type 1. We will go back to our included concepts to do a second iteration to see if there are other things that we potentially want to exclude. And as we will scroll down, we will see, again, all of this general terms, and we will have, again, disorders due to type 1 diabetes mellitus. We don't want that, so we want to exclude it. And as we will go down, which actually not that much scrolling, it's just that it's big font, we will see other things with type 1 diabetes that we want to exclude. So at this point, we made our concept set really big, and now we're doing the process of elimination. This is the task that we have right now. And then we have also another term, and this information you'll be getting from clinical description. Another term that says diabetes during pregnancy, so potentially there's gestational diabetes, that is an exclusion criteria, which we will know from clinical description. So we want to add that, and we want to remove all of these terms from our concept set. So we're gonna do that as well. We're gonna click descendants and exclude. And we will go back to our concept set expression to review it again. So what we have now is all of the type 2 diabetes codes, unspecified diabetes mellitus and its complications, and now we're excluding all of the irrelevant codes like type 1 diabetes, gestational diabetes, potentially secondary diabetes. And really, you can think about this process as of first adding and then going through the lists and removing unnecessary things. Because again, the goal of this step is to make sure that you include as many codes as possible. Now, you may say, I don't want codes with just diabetes, I really want the codes with type 2 diabetes. Yeah. Yeah, it's just the codes. Yeah, that's just the codes. Absolutely, you can.
Can you repeat the question?
Oh, yeah. The question was, is it on the level of codes or patient level? No, this is just code level. We're not talking about the cohort definition. We're just excluding the codes from the code set expression.
Does it extract the whole hierarchy or just the concept you specified?
Yeah, it removes, because we said exclude and descendants, it removes this term and all of the descendants of it. So type 1 diabetes and all of the descendants of type 1 diabetes.
Maybe one more thing, we never
Oh,
use
I should have.
mapped column, so is it the right way or it's useless or what's the purpose?
Yeah, for the purposes of this exercise, we will not be using mapped column. Right, so really the final thing before we move to the exercise, to make sure that you have enough time for it. You may say, I don't want diabetes mellitus as a code, I don't think it's type 2. Well, I will answer you by saying that you don't, at this point, you actually do not know. You don't know what kind of patients are coded using this code. It may be possible, and we think it's very plausible, that these are actually type 2 diabetes patients. And you will only know when you go to the step of the evaluation, and this is when you will actually examine patients and will be able to tell whether these patients that are coded using the broad term are type 1, type 2, or something else. At this point, your guess is as good as mine. And what we want to do is to make sure that we are not losing any patients at this point, because we absolutely will not be able to recover them later through any sorts of inclusion or exclusion criteria. They will be just gone. And with that, we want to move to the exercise.
Talita and Victor, you guys got good teams for us? Okay.
But that doesn't have a number.
It does.
No.
Should we just go in?
20,
So we're gonna make,
So if we have groups of 5 at least, we'll get maybe 23. We need 20 groups.
or we can make more than, we can make 23 teams, and we'll just go back to the top of the list again, that's fine. Okay, so, all right, so if you guys, okay, so Talita and Victor are gonna be going around. Talita's gonna be starting at 1 and working her way up. Victor, you're gonna start over there, and you're gonna start at 20 and work your way down, okay? And give groups of 5 a number, make sure that they know who they are. And all of you, once you get your number, that's gonna correspond to the phenotype that you are going to be assigned right now, okay? So Talita and Victor are gonna get you guys signed up. Those of you who got the email or should have gotten the second email, you'll have a link to the clinical description, which you're going to have a chance to read. The second task is going to be to go ahead and open up atlas-demo.odyssey.org, and you'll have the chance to build your own concept set. All right, I'm going to wait for everybody to get their number here real quick. All right.
I think I slightly caught up on time. Did I?
We're fine. So we'll make it work. Although I don't know. Gotta make sure we have. So you guys are gonna stay in the room for your teams for this exercise. Just make sure that you're sitting with your teams as you are doing this. So you guys can like scoot over and be closer to each other. You're gonna wanna be able to talk with each other. How are you?
Good to see you. Good to see you. Taking the photos for
Awesome.
Peter and everything.
Very good.
Wanted to see you in some action.
Yeah, very good.
That's why when you're speaking, I'm like,
All good. All right. Everybody, raise your hand if you don't have a team yet. Okay. Keep your hands up if you don't have a team. All right, Talita, you've got two behind you who are unassigned, so you can bring them down. All right, keep your hand raised if you don't have a team. All right, Victor, you got. All right, the coordination is the hardest part, right? Hey, you guys aren't leaving. You're staying in the room. Go back to your seats. All right, raise your hand if you don't have a team. Everybody's up. Oh, you got two. Victor, you got a couple right there. All right. Okay. All right. So I'm going to just go through the rules here again real quickly. You all now have a number. Your number corresponds to a phenotype on this slide, which also corresponds to the email that you all should have received. That tells you your clinical target and gives you a link to read the clinical description for those of you who are not familiar with that particular disease. What you are going to do is first click on the link and read about your clinical description. And then the second thing you're going to do is, as a group, you're going to go into atlas-demo.odyssey.org and you're going to start creating a concept set. I'm going to just illustrate how to do this just for purposes of naming this. If I was doing the, whatever it was, glaucoma, I could just like type in glaucoma, just like Anna showed. Whoops, so let me close this one first. If I were to go to search and just type in glaucoma, I could click on the little search, shopping cart, and that would use the Phoebe tool that Anna just showed, and it would create a new concept set. And what I want you all to do in terms of naming it is at the very top, Anna didn't show just the logistics of this. You can just name your concept set and save it. So what I'm going to ask that you all do is up here, you would just type in Odyssey EU Team 1 Glaucoma. Because you're all different team, you can have different names, and you just save that, and that'll be the thing that you've now just created there. I'm going to delete this one so that I don't screw up Team 1, okay? So as a group, you are trying to create one concept set, or multiple if you have variants of it, as a group. Everybody clear on their task? All right. You got Victor, Talita, Anna, and I walking around to help you all as you create your concept sets. You guys have a half hour to do this. A hint is that it should take you less than 5 minutes, but getting you all organized takes some time too. So have at it. You can do it in 2 seconds? There we go. That's even better. All right, I'm deleting that one. And just raise your hand if you have any questions, and we'll be around to help y'all. You can't leave the room. I'm not going to let you go, Giannis. You must stay. Only for this exercise. The subsequent ones we're breaking up. This one's shorter. That's why we want you to stay in the room. Stay in the room for this. Just for this one. The other ones you're going to break up. For this one, I want you to stay in the room. I'm sorry. It's a hot room. Yeah. Just stay in the room. It's not that long of an exercise. First point is just read your phenotype, create a concept set. Raise your hand if you have a question about it. Oh, there's, you want to go up to that one? Yeah. All right. Feel free to raise your hand if you have any questions.
Because it's not using the right one.
All right, so for everybody who just logged into Atlas Demo for the first time, one trick that Anna showed only very quickly was if you click on the left-hand side, there's a button that says Configuration. And you want to make sure that the record counts is selected on this source that says Atlas Prod. That's what's getting you the counts of the 22 databases that Anna mentioned before. I think as a default, it might actually put it on some other sample data set. So if you want to be using the record counts, which we recommend, just go ahead and just go to the configuration tab and make sure that this record count little checkbox is marked for Atlas Prod. If you have any questions about that, just raise your hand and we'll show you how to get there. Well, I can't hear Alex. I couldn't hear your question. let's take a look and see which teams don't have a saved file, and we can go check on them to see why they don't have one yet. You started at 20, right? Okay. So you got a group 20.
I might have skipped one number.
That's all right.
This is fucking,
What?
this is probably I should take off my other ones. It was super
So
cool.
if we
Less than 20 groups and
we had less than 20.
yeah, because some people said they were leaving or they were not participating here.
Okay. Can we just try to see who doesn't yet have a, like, since you guys know who's which team, let's just try to make sure everybody's got one in here anyway.
They put the number in.
Yeah. So team 1.
Team 1 is over here. It's this one here. But
Let's see, I don't see a team 1. So
should
can you
add the number.
go ask them? And then you started at 20, right? So 20 has its one, 19, 18, 17, 16, 15, 14, 13.
Oh, I saw 12. Odyssey team.
Oh, there we go, good. 12, 11. I don't see a 10. You want to go find team 10? I don't see a 10. Here, let me refresh again. That's the one.
Yes. Can I do it on the microphone?
Or so, do you know which? Or did you give out 10, or was it Talita gave out 10?
I think I had 10 over here somewhere, but
recording it, like Odyssey, Team 1.
Yeah, just something so we see the team 1. That's what we need to see.
Any other?
Team 10. I didn't
Oh
see
no,
that.
I got to 9 here. So you started with 10?
Yes,
No,
I think I
right? So
somewhere
you,
team
oh no, you
10.
started with 20. Yeah.
but I got up
Yeah.
to 10. So 10 is
Yes.
missing, right?
So 10 will be somewhere here.
Come on. Come on.
It's updating the
Yeah, I'm trying to look. I'm trying to refresh it to get the latest list.
too many people. Working.
Yeah, I asked Lee to scale up the server for purposes of today, so should be okay.
Team 10 will save. It's right over here.
Got it. Okay.
Team 1's not there yet.
So-
Well, they're
So we had, so one hadn't done it, but they know to do it.
they know it. Well, yeah. Yes.
3, 2, 4, 5, 6. Don't see a 7.
7.
Don't see a 7.
7's around there. You can go ask them.
Yeah, if you can go ask 7.
Any more teams missing, Patrick?
7, 8, 9. No, I think that was it. 8, 9.
Excellent. I'm on standby for questions. and
So there's a
requests.
total of 20 teams. Okay. Good.
Yeah, we saw some people also go out and they want to join the group, so actually that helped with getting 20 teams at the end, right?
Okay, good. So 22, that's good.
Are you good holding steady?
Yep,
Like
I'm
a
good.
machine?
I'm good. I'm good.
Rumor has it you're a robot, like Bender from Futurama.
Erica likes to say that.
Number 7 should be there.
Okay.
They also saved it.
Perfect.
So I'm not sure.
All right. Why don't we, if you guys wouldn't mind, let's just take one sweep through and see how they're doing, like how
How
much
they're
more
doing,
time,
yeah.
just like get a sense of how much more time they need.
Yeah,
I'll
I'll
start
go
here.
left. Yes.
Well, I'm gonna be kind of flexible based on how much time they need. Was that? No? No, I'm logging in, just refreshing to get their current progress.
Okay, since I forgot to show how to look for map terms, I'm gonna walk around the room to see if anybody looked at the source ICD terms that map to those standard
They
terms.
shouldn't, that's fine, they shouldn't need that. Yes, sir. That's a good question.
From the perspective of what you said, that we look for sensitive specificity, people with depression have had depression with greater index of specification because it hasn't started now, it started somewhere before. So that's the question.
Yeah, it's a legitimate. Well, so you think about it as an entry event. If you observed a person that was the only code they had, would you want them to be in your cohort or not? Which is what Anna's saying. So like, they probably had depression. They probably just haven't been in that state. On the flip side, you could say, well, maybe we want those people, but we want them to leave when they're in remission. So you could actually think about an exit criteria, which would use the remission codes, for example, if you thought that the disease could go away at remission, if that was a belief that you had. To your point, most people think of depression as just a chronic state that you have. You either have short acute episodes or you're just of the state of depression, in which case, then inclusion of that could just be included as part of the set, and it would be okay.
There was a patient that an episode of depression 10 years ago, and he still, or she has this sort of depression in remission. Like, do they really have it now, even if it's 10 years after that?
Yeah, it's not impossible. Yep. Yes. Hi there.
So you could, essentially the answer is that you can do both ways depending on which you're going to want. And you can, in fact, create two concepts. Gets the really
Some people are also in the stage of identifying what substances because what you want is that they what substance ready on the program. Just say that. Okay, most people are refining. So in the concept set, yes. You're already asking, how do we refine it even with like the time window? So yeah, some are getting this further, something forward.
All right. I'm issuing a 6-minute warning. 6 minutes to get your concept set done.
I was gonna say, everybody's like 10 minutes. Started here and everybody's like 10 minutes, like it's been already 4 minutes or 5 minutes.
It's respect and fear. It's both.
I was contemplating something because I've added the database where the database spoke about broadsheet. Is that the only kind of initiative with regard to, say, infrastructure, platform, kind of stuff in the OHDSI environment? Because all the things are in the functionality of the databases and this and that kind of stuff. But the plumbing to get everything ready, are there more initiatives than broadsheet or not?
So there are multiple groups doing Dockerized containers of things.
Yeah.
So Broadsea is the one that we're saying, like, if we're going to do it, let's focus on Broadsea.
Yeah.
But there are other people that are basically repeating the activity of Dockerizing things. So if you're thinking narrowly Docker, I'd say like
No.
more general in terms of like infrastructure at that large. I'd say that right now in the community it's kind of split between those that are focused on the R packages and the use packages that are really focused on make sure that we know the right ecosystem for R and database connector and all that kind of stuff. And then there's the web development stuff. And so on the Atlas work groups, there's a lot of conversation about infrastructure and like what's the appropriate web service and all that kind of stuff.
Because the things we do,
Yes, I'll allow it.
you've got respect. And because it's up to me now to go and creating the platform and select what kind of tools it is. Because one thing about selecting the tools is even for functionality in the DAO. In my searches, maybe I wasn't searching correctly. I couldn't find a lot of information apart from others analogs that initiative.
We're not very directive about it.
No,
And
and
I'm not saying we shouldn't be. I'm just saying like we're not. Everybody kind of comes with their own tech system, which is really
yeah, so basically, what I was thinking is I've already spoke sometimes with Peter also. It might be beneficial things we are learning about how to create a platform that we absolutely made something available to the community also.
I would actually explicitly say Darwin reference infrastructure. Like
Yeah.
your entire stack should be a reference infrastructure.
Yeah.
And we should say like, you want to do it like Darwin? This is exactly and
Exactly, because I think
other
there's
people would look at it like, oh, well, I want it to be like Darwin. So I'll just do all those things.
exactly and because I'm creating all those infrastructure pipelines and people getting mad about crazy about me because I say I want to automate everything because I don't want to manage anything, so I want to automate everything. So that's kind of difficult, but you know, and
Yeah, so the Evans is driving Broadsea, and it's like that's I'm not saying this right, so like it's pretty good that right now people are able to download that container and it works like
but
pretty well.
that's something great for your own developer machine or developer VM or something on premise.
Yeah, not once you start having.
But if you say, okay, our company want to do the whole shebang and we want to do our ETL and we have to scale up and that kind of stuff, then they have to really invent the wheel again and again and again, in my opinion. Maybe I'm seeing...
Like we don't use like the JJ, we don't use any of those Dockerized containers. We have to manage our own environment.
I'm not using any Dockerized stuff also because I
say that it's ready to mature, but like, you need to have more ownership of it.
I need to run production stuff.
Exactly.
I don't need to run dev stuff.
Yes.
So, authorization is good, but it can also be full-blown, whatever. I don't mind, you know, that's something that can be. So basically, if you're going forward with all into production stages and that kind of stuff, it's even a couple of months ago, I talked to Peter, maybe giving back to the community, that kind of stuff, then I'm gonna write it down, and also something that can be given back to the community.
And framing it as the Darwin reference infrastructure
Yeah.
would be profoundly helpful, because then it's not just Erasmus is a video about it.
Right.
And you're not asserting, we're not saying this is the way Odyssey has to do it. You're saying this is the way Darwin does do it. And people will say, like, the industry will be like, I want what they're doing.
Yeah, and basically from the support side, you know, I'm not an Erasmus member, I have my own company, so if I think we need to have people who help us create a pipeline, automating that kind of stuff, we can find us all the time. So then we can help them with that. So then we have kind of full stack, and you don't throw it in the deep and good luck. It might not be sound like
No,
that.
I hear you. I think that Docker Station is a great solution for the one-off site who has their one database and their one site. Like, I think that's actually the future, but like, a lot of in enterprises want to use this thing for real, but then it's like, you need something much more sophisticated.
Yeah, but even then it can be that you need to have.
And you want to send it to snacks, right?
Yeah, and they are taking the Korean
Yes.
away in 15 minutes.
Okay. All right. You don't have to leave, but many of you I know probably need some caffeine, and you have 15 minutes to get as much caffeine as you want. So please go take your break and enjoy some caffeine and snacks downstairs. And if you can come back at the bottom of the hour, that would be great. I'm sorry, at what time would that be? 3:30. So 15 minutes, please go drink coffee. Okay, so y'all got some exposure to building your concept sets. How many of you feel like your concept set is 100% perfect? Raise your hand. How many of you feel like it's 80% good? 80% good? Okay. How many of you found using the tools helpful to get to 80% good? What was missing? Share, like why are you not at 100% and you're only at 80%? What do you need to get over the hump? Need some clinical expertise. So yeah, we gave you a clinical description, but you feel like it'd be better if you had an expert in your group. Of course, you just got randomly assigned a disease. Kind of an unfair thing, sure. What else? Yes, Yannis? Yeah. So it's a little bit hard to like, unless you have a lot of experience with the vocabulary, it's a little bit hard to like know how you're navigating it, how to go up, and whether up's going to be better or not. Yeah. Giannis? Feedback. So right now you're on this step of building a concept set, and you're saying, well, we really want feedback. I'm not saying that it's right, but very deliberately, the feedback loop we have right now is when you actually start interacting with the data. And at the point that you're creating a code list, you're not actually interacting with the data, you're just interacting with a code list. So tomorrow, hopefully you'll see more of that feedback, and that iterative loop will get built in there. What else did people feel like they needed before getting from 80% up to 100%? Anything else? Yes?
I need to know the context of the creation of this phenotype within research question, because it's different if you create this phenotype for exclusion criteria and then the study that being the outcome of the other. So to be more
So I'm going to restate your question both so that we get it recorded and to make sure I heard it correctly. So you're saying that you'd like to know the context in which we are going to use the phenotype because that would somehow guide your selection process. We're definitely going to talk about that part of today and tomorrow, and I actually think I'm really glad that you brought that up because it's a really important point. I will make a statement that I know, is Christian here? Is Christian back? He's doing his Christian thing? Okay, all right, so just for the record, I'm not talking behind his back, he's just not in the room. Christian and I have been having active arguments about this very point. My assertion is that if you do phenotype development evaluation correctly, you should not need to know the context. And my assertion is that what you are attempting to do is model the correct disease state of a person who satisfies the criteria for a duration of time. Now, where the context actually matters is not in creating the phenotype or creating the concept set, it's in that sufficiency criteria for when you're going to go use it. If I give you a phenotype and I tell you about its measurement error, you could then say, for my context, that measurement error is too much and I'm not willing to accept it. That I've got something that's too sensitive or too specific or what have you. So in the context of its use, the adequacy criteria might matter, but for purposes of creating the phenotype, I would assert you don't need the context. What you need to know is the clinical idea, and you are attempting to model the clinical idea as best you can. That said, that's my position. There are other people who have different positions that actually believe you would make different choices to create different logic under different contexts. My counter-argument there is that the reason you are creating those different logics is because you believe you know what is happening to the measurement error, and you think that you can think your way through that problem. And the assertion that I'm going to try to push on you today for this section and tomorrow is that we need to actually treat measurement error not as something that you can think your way out of, but we need to actually treat that as an empirical process that you can quantify and adjudicate. Yes? Yeah.
I just think that because we were in the same group, that our exercise was complicated by the fact that the word we got is by some people interpreted as a symptom, whereas for others it's a disease. And within the area, the disease area, the experts are very in a very big disagreement.
Yes. Oh, so you guys did depression, right? Yeah. So the context in terms of like what is the clinical idea? One of the things that Anna tried to highlight, and I'll reinforce this, we believe it's super, super critical that you reach alignment about the clinical description. What is the idea that you are trying to phenotype? Getting that aligned is super important because otherwise, if we don't know what you're trying to target, we can't even evaluate against the target. What I was talking about specifically is that if you have that, I would assert you don't need to build a bunch of different phenotype algorithms depending on context. But if the context was, we don't know what the actual idea is, and we got other question here about like breast cancer, like is breast cancer all breast cancer or female breast cancer? Getting that clinical precision right is absolutely essential for sure. All right, any other thoughts? Yes?
I feel like most of the recommended codes that we included should be already descendants of the primary code.
So the comment is, I thought a bunch of the recommended codes should have already been descendants. Is anybody here from SNOMED? Yeah, I actually only said that like partially tongue-in-cheek. So Anna did an extraordinary job in her PhD at Columbia, and we spent a lot of time studying this. And one of the things that really came as that I learned a lot from Anna and her research was how much we would like to believe that an ontology and a hierarchical representation should be sufficient, and how often we'll be disappointed by that assumption alone. And the reason is, the reason makes sense. We are actually trying to analytically compute over this ontology. That's not necessarily the reason and motivation for the organization of the vocabulary itself. In fact, in our conversations with SNOMED, they think that what we are doing is an interesting use case because it's so different from a lot of their mindset and going into it. So the ontologies are incredible. The hierarchy and all the work that our vocabulary team does is an amazing starting point. But part of the reason why I'm pretty passionate about like this phenotype problem is like our real problem is because the more I've done it, and I've now done many, many hundreds of these, the more I become convinced that you can't just rely on code plus descendant and think that it's going to be good enough, because very, very frequently the types of extra recommendations that get made are reasonable ideas. Go ahead.
Oh, I was just wondering if Patrick also wants to talk about how it's already very different to what a lot of individuals do, which is taking a list of ICD codes. So now we're leveraging mappings and hierarchies, and a lot of research do not do that. They just come to their clinicians and they ask for codes that are used for billing purposes, and they get this list, and they think that this list is comprehensive. And because they do not see the missing parts, they have this nice fantasy that they got a good list. It might be a good list, but you don't know what you're missing unless somebody shows it to you. So using hierarchies is already a big step from what lots of people do.
Yeah, I've had the personal experience of being told to go replicate some other previous published paper, and if I were to use, or when I use our Odyssey tools and type in that code list that's in the publication, I frequently, well over 90% of the time, identify extra codes that very clearly should be included in the definition of the clinical idea, but they were missed, and almost always they're missed for very silly reasons, like it wasn't in the ICD hierarchy, or the strings were different, and it was very obvious that some student just did a string search in a file and didn't find the other strings. And so, you know, much of the things that Anna went through in terms of ontologic representation, lexical representation, and patient context are kind of like tools and strategies to try to do better than kind of the conventional approach. Yes?
I have a quick question on value set in the from the US.
Yep.
There you heard about the VSAT, and are those tests that VSAT not for common, they're certainly not for open and or colon, but are they used by governmental quality measures? Sufficiently good enough?
Yeah, so the comment is about value sets, and in the US there is, for quality improvement efforts, there is something called the Value Set Authority Center, and basically they just provide lists of codes, and specifically they're a list of codes for purposes of representing specific disease targets, for purposes of producing quality improvement metrics. And so they absolutely can be a good place to start and look and identify codes, and I have done that frequently. Because they are US-centric quality improvement measures, they are not inclusive, or not as broadly inclusive as what we aim to do in the Odyssey community, where we're trying to do things globally. So for example, we don't generally create concept sets that are only based on ICD codes in Odyssey, because we are trying to use standards that will subsume those. But I absolutely have used them as, you know, somebody put some good hard thinking into picking those codes, and much like for your exercise, you could have like relied on the literature or other sources, you absolutely could go out there and take a look at those codes, and it's the good work that's been done there. I would generally not recommend any particular source where you would just take it on faith, though. I think it's this whole evaluation process that we're gonna try to show you as we go through the data in particular, is that you will learn from your data source, and that's an opportunity to improve based on what you see in your data. Yes?
Here, two different questions. One is, how often do you actually trust the hierarchy in a way that it's stated? So I always have the tendency to at least want to check what concepts are included, like with the descendants, because I've also experienced in my research that sometimes even the mapping can be wrong. Then of course, like I would raise the issue, but then that gives you the feeling that you should maybe do that constantly.
If you found wrong mappings,
please go to the vocabulary GitHub issues and contribute your new mapping as a community contribution. If you haven't heard about community contribution, please come to me. You can fix those things. You don't have to suffer from own mappings. You can actually change it now.
So to restate your question and provide a slightly different answer, although I agree with what Anna said. So the question is, if we select something and use its descendants, how often we just rely on that and how often we check it? So I'll just say, from my personal experience, I always check it. I'm not personally as worried about wrong mappings as much as not having enough clinical intuition to know what would expect to be a descendant. So for example, the example that Anna went through, diabetes broadly, if I wasn't an endocrinologist and didn't know something, I might not know that under there somewhere was going to be type 1 in gestational and secondary. So I frequently aim to use the hierarchy. I choose the descendants, but I always verify, not because it's necessarily that it's wrong, but it's because it might have something that I didn't expect or is inconsistent with the idea that I'm going after. So that tab, and we'll go through it again, the tab that has the included concepts, I'm always creating a concept set expression, looking at that tab, sorting by record counts to see where the big hitters are going to be, and making sure that I didn't inadvertently sweep in something that maybe I didn't want. Please. So just to restate the question, so when we're in a situation where there may be multiple different clinical ideas together, so to use our diabetes example, you may be interested in diabetes condition codes, diabetes treatments, measurements for hemoglobin A1C. The question is, to what extent would you just throw them all into one big bundle of a concept set, or to what extent would you split them out? My general rule of thumb that I personally follow is I try to keep the clinical ideas separate. So the idea of diabetes as a disease is different than the idea of diabetes treatment, which is different than hemoglobin A1C. So I would keep those things separate. Sometimes I have seen many people who want to keep the concept sets totally clean within domain. So to only have diabetes conditions and not have any like procedure codes that sweep in there. I personally tend to not be worried about what domains they fall in and more worried about that they represent a clinical idea that I can give a label that means something. So as I will go through here in our diabetes example, you'll see that I'll have different concept sets for those different things, and then I'll stitch them together in the logic, in the temporal logic. Yep. Anything else? All right. So I'm going to do a very quick run through of how to build a cohort definition. I'm going to use our type 2 diabetes example. What I'm really trying to do to illustrate this is just to get you out, breaking out into your groups, to go take your concept sets that you built and start building definitions for yourself. But I'm going to show you a few observations that are inside of the type 2 diabetes example that I know some of you will hit amongst your 10 phenotypes that you are working on. So hopefully some of this stuff will be relevant. I'm going back to a slide that I showed you earlier because I want you to remember this 3 steps. We're going to first try to identify the people who might have the disease. You all just went through the process of creating a concept set, which may have contained concepts in one or more domains. But the idea there is that this is the entry event, so it's the thing that gets you into the cohort, and we want to be as broad as possible to maximize our sensitivity. That's kind of our task 1, is come up with the entry events to do that. Once we've identified all the ways that you could possibly be in, we can now apply inclusion criteria. And you can think of this as, now let's start removing people from that initial set we had who we don't believe have the disease. So applying restrictions against the initial set to try to improve your specificity. And then our last step is gonna be to try to correct for index date misspecification. So we're gonna think hard about how to get the correct start date and end date. And it's been a bit of an evolution in our thinking about this, but I actually think that there's a lot of merit to try to think about these steps one at a time in this order, rather than trying to think through all of them all at once, which is how I used to do it for many, many years, and found that because I want to maximize this or minimize the measurement error of each of the different types, it's very helpful to think about them piecemeal. So we're gonna do type 2 diabetes. We saw earlier that Anna showed how to create a concept set for conditions for type 2 diabetes. So let me just ask, if we're gonna create type 2 diabetes, and we can, I'll make the presumption that the concept set that Anna created was broadly including the conditions. Are there any other data domains that you guys think we might use to identify people with type 2 diabetes, besides conditions? Measurements. So what would we do with the measurement to find type 2 diabetes? So we could potentially use hemoglobin A1C measurements and glucose measurements as values that we could look for, and that could be an indicator that a person becomes a type 2 diabetic. Good. Any other domains? Drugs. So why drugs? We're doing type 2 specifically. Okay, so just to repeat for the recording, so the comment was drugs could be a potential domain, and the suggestion was insulin. And the challenge that was raised was insulin is a treatment that's not specific for type 2 diabetes. It could be used for a type 2 diabetic, but it could also be used for a type 1 diabetic. So there's an open question there, which is if we want to maximize sensitivity, we may want to include it, but then we have to remember we'll probably have to sweep through to figure out a way to get rid of the mistakes. So we have insulin as an idea. Anything else? Just the other glucose lowering drug. So there are other glucose-lowering drugs. There's various classes of them. Some of them, like metformin, may have other indications, just like in the same example of the insulin, where it may be sensitive, but it may not be specific. And so we can think about those together. Okay, yes? So the comment was, if we were to combine the drug use with demographics, one may be able to realize that type 1 was probably earlier in life. And so that's a very good thinking. That could potentially be a way that we could think about number 2, how to remove people that don't have the disease, is we could say, well, the type 2 diabetes should probably be amongst people who are older than 18. So that could be one way that one could try to increase specificity. Yep. So the comment was, in our diabetes concept set, we took general diabetes plus descendants excluding type 1. That doesn't exclude the people with type 1, that just excludes the codes of type 1. But if we now say, let's also sweep in people with insulin, that might now be pulling in the type 1 people, even though they don't have the type 1 code. And so that would be something to be considering as we go through this. Yeah, so I think, if we're on number 2, we could think one way to restrict people who don't have type 2 is we could add an inclusion criteria that says you don't have type 1. And so that could be one way that we would be able to remove that, and that might also pacify the concern as it relates to insulin. Yep, so the comment was, what about diabetic complications? And so where do they live? And so as Anna went through the concept set for type 2 diabetes, some of the ones that she was selecting were things like disorder due to type 2 diabetes. And the descendants of those, most of those are like the diabetic complications like retinopathy and nephropathy and what have you. And so those potentially are getting by having those codes as part of your concept set, that's helping to increase your sensitivity. So step one might be good. A potential concern would be if that's the way you got in, maybe your index date is misspecified because presumably you may have had the disease for longer and you're first presenting later in the disease course. Very good. Okay, good. So I heard from you guys some ideas of how we could improve sensitivity by picking some other domains, heard some examples of how we could improve specificity by removing type 1 as an example. And then also we just touched on index state misspecification. So what I'm going to do is very quickly show you how to just implement these ideas as a cohort definition in Atlas, and then have you guys break out and create your own cohort definitions for your own disease. So I'm going to start very simple. So in Atlas, I'm on the left-hand side selecting cohort definitions, and I'm going to click on the right side, this button, New Cohort, and I'm going to call this Demo Type 2 Diabetes Simple. Now, the simplest thing that we could do is to think about our entry. So I mentioned these three sections: entry event, inclusion criteria, exit strategy. The Atlas interface is actually explicitly organized in exactly that way, so that you will first go through a section whereby you have to define your entry events. You can select the domain of interest. So we could say, well, we know we're going to use those condition records. And then we could, once we're in here, we can import a concept set. And so we already had type 2 diabetes, this type 2 diabetes concept set. At this juncture, with just those 2 button clicks, I have now created a cohort definition. This cohort definition is extraordinarily simple, but I want to explain what I've just done, other than just naming it simple. What I've just said is that you enter the cohort at the moment that you have a condition occurrence of any of those codes in that concept set. You enter at the earliest time, so the first time you ever saw one of those codes. We have no inclusion criteria, so that means as long as you had one of those codes, you're in. And the exit criteria in this case is until the end of observation. So this is making a presumption that once you're a diabetic for life. And so you're going to basically stay in the database marked as a diabetic from the time of your first diagnosis code to the time of your end. Is that clear? Okay, good. Okay. Now, while that was only 2 button clicks, that's not an unreasonable cohort. In fact, 95% of papers that you read, if you think about how they implemented their phenotypes, that's pretty much all it is. Anybody who just gave you a list of codes, that's what it is. It's basically a list of codes in a particular domain, and then just satisfying the criteria. But we just talked about different ideas of how we could improve on this, and so I want to walk through examples of how to do that. So I'm just going to create a copy of this, and let's call it, well, we're going to do a simple, medium. You can probably guess what's coming after that. All right, so let's start with trying to improve sensitivity. So we heard examples of using measurement values for like hemoglobin A1C, and then we also heard examples of including diabetes drugs. So again, this is an entry event, so we may think, as long as one of those things has happened, then I'm going to be classified as in the diabetes state. So I can select those different domains, so I could have drug exposure, and I can import a concept set, which in this case is going to be diabetes, I saved it like 3 minutes ago and already have lost it. There we go. No, all good. There we go. blood glucose lowering drugs, excluding insulin. Now I'm going to show you what this concept set is. So this is using the ATC vocabulary, whereby drug ingredients, and even combinations are organized into a hierarchy. To the point earlier, like, do we trust the hierarchy? Not necessarily. You can always click on the included concepts to see the totality of all the items that are listed underneath of here. And in this particular case, I may be specifically interested in understanding what are the individual ingredients that roll up to this. I can sort them on record count, and I can get a sense of all of the drugs that are under this class in ATC. It was commented earlier. What's that? So I want to come back to that point very specifically. So the comment was, I would want to exclude metformin. And I'm going to infer from your saying that because metformin has another indication, you're concerned about it. And that other indication is polycystic ovarian syndrome or whatever? Okay. So if our step one is to maximize sensitivity, then I would assert we want to keep metformin in, because we want to find as many type 2 diabetics as possible. Metformin is the recommended first-line therapy for type 2 diabetes. And again, I'm going to separate these tasks. Task one, maximize sensitivity. So are there some people who have type 2 diabetes that take metformin? Yes, a huge amount of them, right? So for step one, we might want to think, let's include it, because that'll pull in those people. The reason you're thinking I don't want to have it in that step is because you're already jumping to step two, which is I want to increase specificity. So one strategy could be, let's remove metformin. That would be a way to increase it. But another way to do it is say, what are those alternative reasons why you got metformin? And maybe you want to remove them possibly. Okay, so that's just another strategy we could think about. Okay? All right, so I just added drugs as a way that one could get in. And then the other one we mentioned would be like measurements. Again, you could just select a measurement domain. We could select, whatever, hemoglobin A1C. Just for interest in time, I'm selecting these concept sets that I've previously created. I'll show it to you so that you understand there's no sleight of hand here. Here we're taking advantage of the hierarchy of hemoglobin A1C measurements, which includes a whole bunch of different LOINC concepts which show up regularly in the data, as well as CPT codes. But we don't just want a measurement of hemoglobin A1C. Yeah?
Why is one colored red and the other one is called
Ooh, what's colored red? So in general, things are blue when they're standard and things are red when they're non-standard. Oh, there's a red one. Yeah, so in this particular case, the hierarchy code itself is not a standard code that we would expect to have in the database. And in here you actually see that code itself isn't even show up in data by itself. It's only a hierarchical term. Yep. So in this case, we wouldn't just want people who got a hemoglobin A1C measurement. We'd actually want to see some sort of qualified value for that. And so this is where we can use our domain-specific attributes to say something like, we want a value to be greater than 6.5 with a unit of percent. And so in this particular context, come on. Whoops. Where's my percent? Well, that's percent. Where'd my scroll go? My scroll's gone. Where'd my scroll go? I can't get to my window here. That's funny. Oh, that's a good idea. Did you? Oh, you made it big. Got it. Oh, there we go. Sorry about that. So in this particular example, I've just said measurement value greater than 6.5 unit of percent. Of course, there could be multiple measurements, multiple values, multiple units, but just to illustrate the idea, here I've just layered in. So now we're saying you're gonna be a type 2 diabetic if you had a diagnosis, or you had a drug, or you had a measurement value greater than 6.5. And you're adding these all together as a series of ors, so you're basically expanding the set of people who qualify. So that's improving you're aiming to improve your sensitivity by doing that. Do you have a question? So the question was, how do you do and? So specifically for this first step, where we're doing entry events, there is no and, because you're trying to increase the list. Now, when we do inclusion criteria, we can absolutely add inclusion criteria as ands or ors in any combination of Boolean logic, and I'll go through that as a step. If there was something where, and I don't know, can we come up with an example of this? Maybe for the drug exposure, we want to say you have to have the drug and then later have the diabetes code, just as an illustration. Then you can actually add nested criteria here, whereby I would say something like has a drug and then in the future has at least a type 1 diabetes, and now I'm saying like must happen sometime afterwards. So that's a way that by adding a nested criteria, I'm adding an and requirement to that idea. But for step one, when you're trying to increase sensitivity, don't think about combining things together that will make it more restrictive. Think about trying to make it as broad as you can. Okay. So here we have our type 2 diabetes, and we've now expanded our entry criteria. But there was concerns that was raised about maximizing specificity. So here we can now move to step 2 and think about strategies to remove the people that we now have swept in that we might not want. So for example, we could say, does not have type 1 diabetes, if we thought that that was something that we want to remove because of the concerns about insulin or other things that were made. In which case, we can say, this person has to have 0 occurrences of type 1 diabetes, and then you could decide when in temporal logic you are going to look for that type 1 diabetes. So I might say something like, for example, I'm not going to include a person if they previously had a type 1 code in the past. The other suggestion that was made is maybe the age has to be over 18, because we don't believe that if you had a type 2 diabetes code before 18 that would be considered. Just to illustrate how you might consider that, we could add a demographic domain, add an age criteria, and say you must be greater than 18. Okay. So here, when we add inclusion criteria, we are now starting with a population and we're removing people. And you remove them, each inclusion criteria now is a set of ands. You must satisfy all of those criteria. And what you're going to be left with are the people who started in the broad group and that satisfied all of your criteria. Okay. And I'm not going to restart. So now I have added, in this particular context, I've added entry events to maximize my sensitivity. I've added inclusion criteria with the aim towards, yes? If we added age, sorry. When I click here, up top. If I had done like age here. So you absolutely could, like in this particular case, there's multiple places where you could choose to put the age criteria. If you think of the entry event as the section that you're trying to improve your sensitivity in general, then you have to decide, is age really something that's a hard requirement, or is it something that I want to like evaluate? My personal practice, not saying it's recommended best practice, but my personal practice is I like to add inclusion criteria, because when we run the cohort, we'll actually get to see what happened with the criteria. Whereas if you put that up top, there's no choice to see it. So like if you think of it as a simple attrition table, sometimes it's helpful to see each of the steps as you go along the way, like a funnel plot. You'll see that with all of your inclusion criteria. And quite explicitly, that attrition table really is showing you the steps towards specificity in that particular context. All right. So in this particular case, I'm going to be comfortable with the idea that a person who has type 2 diabetes, once they have diabetes, they're going to stay in the chronic disease state of diabetes until their end of their observation. But I want to just illustrate how one could think about different exit strategies. So if I were to be phenotyping a drug, for example, like users of metformin, then I could think about following them, and in this particular case, I'll select the diabetes drug here. So imagine we believe that they only have the disease while they're on treatment. Otherwise, they don't have the disease, because once they stop the disease, they don't have, once they stop treatment, they don't have the disease. One could actually imagine specifying the exit criteria to be, as long as they're on treatment, they're in the cohort, and once they stop treatment, they're off cohort. For acute diseases, it could make sense to say, there's just a fixed period of time that you have a disease. So like, I'll just say like, I only have the disease for a day. And for some acute things, like some sort of like, minor infection or some spontaneous event, that could be a totally reasonable way to do an exit strategy. For most chronic diseases, where you have some level of confidence that a person has the disease until the end of their life, then this can be reasonable. Sometimes we see that there may be something that is possible to be observable that would become the item that would, I'm sorry, let me restate it. Sometimes there is something that can be observed that tells you that a person no longer has the disease, in which case you could also enter a censoring event. So I'm making something up that does not apply to type 2 diabetes, but imagine there was a code that says type 2 diabetes in remission. Then we could actually say, you stay in the disease state until you hit the point where you have that marker that tells you you no longer have the disease, which came up in an example earlier as an example, okay? So just want to show you kind of this set of tricks. The way that I would recommend that you now break up into your groups and start working on your cohort definition is start by thinking about your entry event. Think about the domains that you might be interested in. Most of you got through, and I looked at them, so they look pretty good. You did a good job of creating a condition concept set, and for many of your conditions, that might be the primary entry event criteria that you're going to be using. I want you to go back to that clinical description and think about what it told you about differential diagnoses and other reasons why a person might not have the disease even though they have a diagnosis, and you can think about those as adding inclusion criteria. Or if you think that you're needing to see other markers in order to increase your specificity, like requiring to see treatment or something, you can play with those. What you're doing at this point, and it can be as simple or as hard as you want, is you're going to create a cohort definition in Atlas, do the same trick, please name it OHDSI EU team 1, and write down the disease. You're creating a definition that you think is a good starting point to start your evaluation. And what we're going to actually do tonight is get your definitions that you finalized now, and we will run them across a collection of databases, and then you're going to be able to observe what actually happens when we apply that definition to data. It is almost always the case that this would be an iterative process, that you will guess at a definition, you'll do a pretty good job, but once you evaluate it, you'll say, oh, I'd like to go make some changes. You'll observe sensitivity errors. You'll observe specificity errors. You'll observe index statement specification errors. And once you observe them, you can go back and iterate on your cohort definition. So right now, think of it as you all are doing iteration 1 of this iterative process to create a good enough definition to be able to allow Anna and I to evaluate it tonight. Make sense? Yes.
Would you typically create 2 concept sets, one for cohort entry and another one for inclusion?
So the question was, would we normally create 2 different concept sets? So if, in this particular example, I've pulled in 4 different concept sets representing 4 different clinical ideas. And so it could be very reasonable that in your definition you may have multiple concept sets, and that's totally fair game. If you were to end up in a situation where, for example, you had something like type 2 diabetes broad and then type 2 diabetes narrow, then you may end up with 2 concept sets and you're making some choices about how to use them. I would argue for your first iteration, you're probably doing an awful lot of guessing if you think you know what broad and narrow actually is. You'll probably learn a lot more from looking at the data when we get to that point. But yeah, right now, as you go as you break up in your teams, you can create one or more definitions if you want. If you want to run one that's a simple definition, that's just your condition concept set and just hope that that works, you absolutely can. And if you want to build a more complicated one that tries to anticipate the sensitivity, specificity, and index date errors, then feel free to create that. The goal is we're going to just come back to this room with, let's say, I'm going to give you guys a full half hour, I guess. So why don't we come back at, is that right? You just looked at me. Is that good? Yeah. So if you guys can just come back to this room at, what would that be? 4, 5, what time is it? 5, yeah, 5 to 5. 5 to 5, come back here, just so I can tell you what you can be planning for tomorrow. If you want to stay in this room to work as your groups, then feel free, you've got the space. If you want to go sit, like you're staying in your same groups, you're working in your same teams, but if you want to like walk out and sit at one of the small tables or in any of the other rooms, you're totally welcome to do that. Talita, Victor, Anna, and I will be walking around both this room and wherever you all meander off to provide help as you guys are doing it. Is the task clear? All right. Happy phenotyping. Okay. There's some groups that don't have a hand raised. All right, ask the question again. How many of you got at least one cohort definition done? Okay, most everybody. Almost there. We'll be done by the time I stop talking. Okay, good. Okay. How many of you feel 100% good about your definition? You feeling good? The definition's not good, but you're feeling good. That's, as long as this has been entertaining for you, Giannis, that's fine. Okay, how many of you feel like 80% good? Using that same approximate logic. Okay, a few hands. So what made, for those of you who had your hands up, so what made you feel generally kind of good? What was it about the experience? What was it that you saw that made you feel okay? Listen. Got it. So right now you have a definition and you couldn't come up with a very obvious counter argument for your definitions. That's why you feel kind of good. Okay. And when we evaluate it, we might be able to see empirically some of those counter arguments. But right now you couldn't come up with it off the top of your head. Yep. Okay. Yes. Pretty. Okay, very good. Giannis? Oh, sorry, go ahead. Bounded by. Got it. Yeah, so this is it? Yeah. So you guys had a little bit of an unfair situation that we threw you into groups, told you to have a clinical idea you may not be an expert in. And so you may feel kind of good about it simply because it's reached the depths of your clinical knowledge about that disease. And the only way you're going to get further is do more research into that clinical disease. It's almost as if only there was some sort of like open community of researchers who could collaborate together and share knowledge. If that only existed, then maybe we'd be in a better place. Okay? Yes? Got it. Yeah, so Got it. So Atlas is showing you that there's a lot more features that you could take advantage of, even though you may not have either had the time or the thinking to get there. Yep, yep.
I think I got to a point where I feel that the criteria that I wanted to apply, they are also possible to apply. So
Got it.
that's really nice.
Good.
But on the other hand side, I also got to a point where I would apply different criteria for different data sources because I know that the mindset of registering things is different from a healthcare system to healthcare system.
Yes.
That's where I come short of the federated network thinking.
Mm-hmm.
I want to do different for data sources.
So this is a good comment, and it'll actually be a really nice segue into tomorrow. So the comment is that if you knew something about each database, maybe you'd find yourself trying to tailor the definitions for different data sources. And here, of course, I gave you the task of creating a phenotype. You don't even know what data we're going to run it on tonight, so you have no idea. To playfully challenge with your comment, if you think about that there would be potentially different ways to apply logic, you don't necessarily have to believe that those are going to be different phenotypes. Instead, you can think about how could you create one logic that subsumes those alternative ideas together. In very like simplistic terms, like think of it as like a Boolean operation. It could be like A or B. And then if you created that one approach that had those alternatives, now you know that for that database that you wanted A, it'll work, and for that database you wanted B, it'll work. And it is important, I would assert an opinion. My opinion is it's important to try to create a definition and see whether or not it will work across the network, rather than presume that your definition will only work in one source or another. Yes? That's right. So what we are going to do, so that the comment is that this could require updating each time you have a new data source. So I'd say only like 20% of you raised your hand that you're 80% good. I hope that the 20% of you that think you were 80% good, it'll be a smaller proportion that feels like they're 80% good after tomorrow. In that, what I hope will happen is that you will gain confidence that either your definition is good or it's bad once you actually look at the data. I think right now you are still in a situation, you created a concept set without data except for record counts, and you've created a cohort definition, but you still haven't actually seen what happens in the real world when we apply the logic to a data set. And so tomorrow is going to be all about that. We're going to take your definitions, we're going to run it across a selection of databases, and you'll get the experience to see what happens. And the primary assertion that Anna and I are going to try to leave you with is you need to be able to run your definitions across the network to be able to actually know how well it's going to actually work across the network and not just guess at that game. So we're at time today. If anybody didn't finish and wants to finish something up and has any questions, you're good now? Okay. So Anna and I are going to take the definitions that you all put in, and we are going to have stuff available for you to be able to play with tomorrow. Yes? Yeah, so as long as you saved them with your team name, if you had multiple of them, that's totally fair. We're going to need them in the next 15 to 20 minutes. So, all right. And if you're working on one, just let me know. We'll figure it out. Yeah, so just so you all understand the process of what's going to happen, so Anna and I are just going to do a quick QC check on things just to make sure there wasn't some silly little bugs that I'm accustomed to making myself. And then we are going to run cohort diagnostics across, I don't know, as many databases as Gowtham feels like doing tonight. And then tomorrow we will be using the cohort diagnostics interface to look for those sensitivity, specificity, and index date misspecification errors in your definitions. And then you'll be able to at least go through that process of iterating. Anything else? Okay. All right, so I think y'all should go have some fun in Rotterdam, and I'll see you all. What time do we start tomorrow? What time? We'll start at 10. We'll start promptly at 10. So be here at 10 because we get kicked out at 12:30, and I want to make sure that you guys have plenty of time to have fun using the tools tomorrow. So see you all in the morning at 10 o'clock. Thanks, everybody. What's that? No applause.
There was this group up there, they had an issue with this concept set that they created. They said there are people in this concept set, but when they put it as a